Welcome to our roundtable discussion on options to address the resource challenge. So who are we? Well, let's do a roundtable starting with myself. I'm David Peck, Delft University of Technology, Faculty of Architecture and the Built Environment. Juan, tell us who you are.
Juan Escarte, also from TU Delft, Faculty of Architecture and the Built Environment.
Max Brumbaum from the TU Cluster, the Institute for Mechanical Engineering.
I'm Esther van der Voet, Leiden University. You've seen me already in the first lecture.
I'm Anna-Karin Jömbrink from Swerea, a research institute in Sweden.
And I'm Armin Lohrengel from the Technical University in Clausthal in Germany.
Fantastic. Esther.
Thanks, Dave. Yeah, this debate is about basically an introduction to the whole course. I've just introduced you to the resource challenge, and if you will remember, it consists of three aspects. The first one is securing supply. We may have issues in the future with not having sufficient resources. Second one is reducing waste by using all of this and then discarding it. We have huge waste streams. And the third one is the environmental pressure that goes with the production, consumption and waste management of all those resources. In this course, we will talk a lot about the circular economy. And the circular economy is mentioned as a solution to this resource challenge. We've shown you the butterfly diagram about all the different options to close the cycles in the economy and keep all the stuff in use rather than discarding it as waste. So now we will briefly go into the different options, the options that we will treat in this week. So that's going to be reuse, repair, remanufacturing and recycling. And for all of those options we will briefly inventory how they may help solve the resource challenge. So that question I'm now going to ask to all of you. First, you, Juan, you are in charge of the reuse week, which is going to be week 2 in this course. So could you tell me what is the potential of reuse to solve this resource challenge?
Yeah, sure. Well, the idea of reuse, of course, is to extend the service life of products as much as possible. And of course, the longer you keep a product in use, the longer you prevent it from joining the waste stream and having to do something else with it. And you also avoid having to spend more resources and more energy into generating or creating a new product to replace the one that you just discarded.
Yeah. Thanks, that's very clear. Just by lengthening the lifespan, you will be able to mobilize less resources to actually fulfill your needs. Exactly. The week after that is about repair. So Max, maybe you could tell me how repair will help solve the resource challenge.
The definition of repair and the idea of design for repairs and design of a product which is easy to dismantle, which is easy to open, that you can change a broken part of your product and the lifespan of your product will increase. So there's less need for new parts, for new products. So we need less new materials, similar for the design for reuse.
Yeah, so there's a lot of similarities, you would say, between reuse and repair. Obviously, if you repair stuff, you do need some new materials, but not as much as if you want to create a whole new product.
Yes.
How is this for remanufacturing, Anna-Karin?
Well, remanufacturing means that we keep the value and the resources already put into the products and to the components. Not only the material, but also the resources used for production and the production processes, which are then kept, since you don't have to produce the components of the products over again. And this saves a lot of resources and reduces the environmental impact by that.
Thanks. So it's another story of keeping stuff longer in use,
Yeah.
so that you can avoid having to mobilize new resources. Armin, how about recycling?
Yes, recycling is the final step in the CE loop. Recycling means that we break down the product into its material pieces. Therefore, we destroy the value, the complete value of the product, and that costs energy and for sure also additional effort. Therefore, it should only be the final option in this case. And however, the consumption comparison between the recycled product and the products coming from primary resources is positive. The potential of the recycling process is that it keeps the resource in use, and therefore it reduces waste streams for sure.
Okay, thanks very much. So if I summarize this, we can basically see two mechanisms of how a circular economy may actually help reducing the resource challenge. One is keep the products in use longer. The first three options discussed are really about that: reuse directly and repair, and also remanufacturing by, well, replacing parts or components, and therefore avoiding having to produce a whole new product. This obviously will reduce the amount of resources that we have to take out of the environment, and also to produce them, so it may avoid some environmental impacts in that way. Now, recycling is another thing that is, the product has to come to an end of its lifespan sooner or later, and then we have still to do something with it if we want to close cycles completely. So you say it's a last resort, Armin. I say it's a very essential part of the whole circular economy.
Yeah, of course.
Dave,
Yeah.
could you discuss some of the drawbacks of each option? We have just heard how they may help solve the resource challenge, but there's always another side to it.
Drawbacks and questions that we don't
Yeah.
understand well enough. So for a start, and you quite rightly summarise, is that the options we heard in the room sort of fall into one general camp and another general camp, where we're extending the product life in one instance and then talking about recycling. What I'm unsure about is in terms of extending product life, we tie up a lot of materials. So there's a flow. We do have new products which have to feed the system in order to repair, reuse, remanufacture. And then we've got an outflow, hopefully, into recycling. But we're changing the balance of that system. So we're tying up stocks of materials. So how much and over what time, what rate are we doing it? And I'm not quite clear on that myself, and I know other researchers are concerned about this as we go through this change. So we need to make sure we understand that. We can do it, but we need to make sure we understand it. I'm uncertain. I have some questions about replacing parts, taking things out, individuals perhaps, or companies doing it. So we need to be careful we don't actually start to generate whole new waste streams as we take parts out to repair or to remanufacture, that we're changing things and we're just generating new waste in a different way. So we have to secure that we don't do that. We've got a lot of things moving around in this new economy. So I'm a little bit unsure, what's the environmental impact there? So are we gonna make things worse in moving around? Are we gonna have roads and whatever full of stuff moving around? We've got to make sure we don't do that. And I think I'd pick up on your final point, where we really have to make sure when we're closing the loops of materials, yes, we have longer product life for various options, but in the end, we have to ensure way more material goes into the recycling loop to get it back into use again. So those are some of my concerns and drawbacks that I see. There are many more, but there are things that we're working on.
Something you would like to add? Yeah?
Yes, I really would like to add the risk of toxicity, which is one challenge here. We see that some of the chemical substances we put into products in the past might be shown today that they are dangerous
Yeah.
or even forbidden.
Yes.
And then we
Yeah.
have to be sure that they are not put onto the market again in new
Indeed.
products.
Yeah.
So we have to be a bit careful with that.
Mercury, lead, cadmium.
Yeah, and
Materials
those
like that,
flame retardants. And
Yes.
yeah.
Okay. Yeah. I agree.
Yeah, an important point. There's also something else. Armin, you just talked about energy. It also takes energy to set up a recycling system, and actually the process of recycling takes energy.
Yeah.
Is that also something that is relevant for your other three options, the reuse, the repair and the remanufacture? May there also be energy drawbacks there?
Well, in the case of reuse, of course, there's a drawback that you keep in use products that might eventually be less efficient than the new equivalent. So if we think of a washing machine, for example, if you keep using the washing machine that is 20 or 30 years old because it's just very reliable, it might be that it's less water efficient and less energy efficient than if you just replace it with a new model. So in that sense, it could be, in the end, a drawback.
Thanks.
Yeah, I also see all these transport of things, as you mentioned, as a possible drawback also for remanufacturing, because you have to gather enough similar products of the same kind to a single spot to make a remanufacturing facility working well. And that means probably a lot of transport. But we also see in companies putting different remanufacturing sites on certain spots globally to make that to minimize those transport efforts. But that's something to consider at least.
Right, and I guess we will be coming back to that also in the next weeks. It's clear that well, there may be a large potential to actually reduce the resource challenge, but there's also some things we have to consider. And yeah, in the next weeks we will be going more deeply into the different options to close cycles, and then we will address this issue as well. Next question that I have for all of you is, well, of course you can think about all your options in a technological sense, but how easy or how difficult would it be to realize your options? Juan, can we start with you again?
Sure. Well, in principle, reuse, of course, is the easiest one to implement because it's just about continuing to use the products that you already have for as long as possible. Of course, when we think about the next generation of products, that will actually should be designed to be reusable with that purpose in mind, then we should purposefully design them to be more durable, to be more robust, and so on. And well, of course, one of the questions, as I mentioned before, is how to critically evaluate when it's a good decision to reuse against when it's not. For example, in the case of buildings, if you just reuse the building for as long as possible, it might be that it's not as energy efficient as if you decided to renovate it or repair it into a new system.
Max, could you say something about repair?
Yes. If you look at the design for repair, we have many options to design a product to make it easy to dismantle by hand or less tools and simple tools. So from the technical point of view, it's easy to design product for repair. The question is about the business model. Yeah, how do we get the companies that they want to design a product easily for repair? So that they may grow by selling technical service or spare parts and not by selling new products on and on.
Yeah, that's right. Anna-Karin, could you say something about remanufacturing in that respect?
Yeah, I think it's quite easy from a general point of view to go to remanufacturing, but there are many things which need to be in place to make it possible. And one main thing, I think, is making an infrastructure to collect the used products, to get enough of them at the same spot. But still, if the products are designed for remanufacturing, it becomes easier and more profitable, and thus realized, I think. So that's the thing for you to do.
How about recycling, Armin?
Yes. Yeah. As long as your product consists only of a few different materials, then recycling is not a big deal. The big challenge in doing a design consequent recycling product is the increasing complexity of modern products. If you think of a mobile phone, for example, this mobile phone consists of several different materials that are combined inside of the device, and to separate these different elements is a hard job, which needs high efficient and high-end technology. And therefore, most of the time, you have some problems regarding the concentration of these elements. They are in a very low concentration inside of this device, and therefore we have the problem that a lot of elements in the world have a recycling rate that is lower than 1%.
Because they are used in such very small quantities, low concentrations, that they are difficult to get out.
Yeah.
So if I summarize that, it seems that from a technological point of view, design for reuse, for repair and remanufacture is not really a problem. There are issues, of course, with setting up the systems to make it actually happen, but technological, it's not a problem. With recycling, there are some issues.
Yeah.
So here we really have also a design challenge that we will go into in the coming weeks. Dave, Anna-Karin just touched on it. Things that have to change in society to actually make this happen. Could you say something on that?
People in society. I think this is key. We know from the past, if society doesn't engage into things, we do a lot of talking, but nothing happens. So I think there's some changes going on, and I think there are some, as you say, there's some drivers and some barriers with how society is responding. There's a few things I'd like to pick up on. One, globally, societies and governments all around the world have agreed to do some things. So I pick a couple out. One is the United Nations climate change agreements around the world, and two, the United Nations Sustainable Development Goals. All countries, or most countries in the world, have signed up to this, and societies have said, okay, yes, we will do these things. So there's some drivers there. But companies, we have a financial economic system. Companies need to make money. So this is a big change that we're talking about. It's not a minor thing. This is not just a little bit of greening. This is a complete revolution in how we run our economies and how we run our societies. And how companies are going to make money on that is different. It's not necessarily a massive challenge, but it's different. And at the same time, when companies are making money, we need societies to feel that they're not being cheated or ripped off in some way, that it's fair, that it's an equitable way, that they can buy into it. So I think those are some barriers and some challenges we've got. But coming back to some drivers, I see in society increasing concern over the effects of climate change, increasing concerns over the effects of waste. We see this, for instance, over concerns with plastics in the ocean. So suddenly we're getting more and more societal awareness of something has to change. Time is now, and time is also urgent. So the idea of putting this off for tomorrow is beginning to change in society, and people are saying we have to do something now. And to conclude on this, I also think that there is a sense of there is new thinking and new opportunities in what we're discussing in this course and many others, and this leads to new opportunities in terms of careers and opportunities for people in society and how they're going to live and how governments can interact with this. So I'm quite optimistic about where it's going to go. I think there's going to be some big opportunities.
Yeah, I guess you're right if you say, well, the time is now. That's, with all the global challenges that we are now being increasingly aware of, it's a good time to start these things. But at the same time, of course, it's large changes that have to be made, not just technologically, but also in society, in policy, and at a global level. So this is really key, I think.
Yeah, can I add something?
Sure.
I think that from companies, I think if they want to stay or become competitive in the future, they really have to take care of these things to consider sustainability. So if they work on circular economy and if they manage to do things right,
Yeah.
they will be competitive in a sustainable society.
Yeah. Yeah.
And that's what I think they should aim for.
Yeah. Yeah.
No, I think the first step for this is to keep in mind the value added to a product, and that the company wants to save these added value, and that's, I think, one of the key facts in our MOOC
Yeah.
that you have to realize. Yeah.
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 Yeah. Well, with those words, I hand over back to you, Dave.
Well, indeed, and then I'm talking back to you, our delegates and learners on this fantastic course. In the next few weeks, we're going to go into way more depth in the things that you've heard around this table. You will explore, begin to understand, you will find opportunities to find these solutions. I do want to say as a concluding point, and when we were talking about this massive change and this massive opportunity that we're talking about in this course, it's you that can make the difference. And we've all agreed on this. It's you out there that can make a difference in what actions you take, and the things you learn from this course can make a big difference. And we look forward to talking with you and working with you over the coming weeks to help you realize that opportunity. Thank you very much.
Thank you.